Welcome back, guys. Today we're getting nerdy with 3D printers. How's it, guys? My name's Andrew, and this is the Make It and Break It YouTube channel, where we show you the process of designing, building, and sending project cars and motorcycles in the motorsports arena. Today we're working on our Project Ute Chrysler 300C, and we're going to design a new hood pull tab and go 3D print it on a little small commercial 3D printer at home. We wanted to bring you along and show you how to do it. Gosh, where do they put that thing anymore? I'm like the poor dude in this garage. So, oh, there it is. So I'm gonna go get into the car and we're gonna take some measurements first, because my design motto is measure once, cut twice. No, measure once. No, measure with a micrometer, mark with a pencil, cut with a chainsaw. That's proper design. So we gotta go measure this thing here, because without measurements it's really hard to CAD something and get it to fit the way you like to. So I would normally do these measurements here with a like digital caliper setup or something like that, but mine is out of battery and I couldn't find the right ones. So instead what we're gonna do is we're gonna use this little kind of gauge little thing. Has a bunch of different ways to go test like threads and fitting diameters and things, but we're going to use this wire and drill section of it here. And what you kind of do is you put like a wire or drill or something through this section and run it up until it contacts and stops, and that'll give you like a size measurement for the OD of it, which is close enough for us here. We're not looking for like perfect precision fits. We just want to have an idea of how big to make all the holes in our thing. So I'm gonna go do that here real quick, and I'll see you guys back in when I'm sitting down in CAD. All right, everyone, we're back home, and now we're gonna take those measurements we took from the Chrysler and translate them into an actual usable plastic part. So this video is kind of intended to be a primer on how to go print your own parts for your car, and it's also kind of intended to show you guys that cheap, affordable 3D printers, kind of like this one I have back here, which is a Monoprice Select Mini V2 or something like that. It's like 180 bucks on Amazon. Are not just for printing little toys. They can print actual useful things for you. So kind of what we're going to do here is I have my computer open, I got my CAD program set up, so I'm going to go in and do some CAD work, get our pull tab design finalized here, and then I'm going to go and show you guys the program I use for translating your CAD parts to something that your 3D printer can understand and use. It's G-code, if you guys are familiar with kind of CNC work. And then we're actually going to go print it on this printer back here, and throw it together and put it on the car and go about our day. So let's jump into CAD. Okay, everyone, we're in our CAD environment now. I'm using SolidWorks, which is a full professional CAD program, solid modeling program. It is quite expensive, and I would not suggest that to pretty much anyone just starting out with CAD. If you have CAD experience, or if you learned on a certain program, absolutely go get it. But this version of the programs that I have is about $9,000, and even the cheapest ones, I think when I was looking at it, was about $4 grand, $3 or $4 grand. But they're a lot cheaper, and I think there's even some decent free CAD programs out there for those of you who want to draw up your own parts. If you're curious about what they are, let me know down in the comment section down below, and I can provide you guys some feedback on what I think looks good and what doesn't. But this is the program I used in school learning, and it's kind of the program I've stuck with since then in my own personal use. I do want to stress that in order to 3D print car parts, you do not need a CAD program of any style. However, if you don't have the ability to create your own parts, you have to go find someone else's part files in order to send them onto your 3D printer. There's good websites like Thingiverse and other places where people just put up free or like low cost. So you can go get those files other places. If you have a friend with a CAD program, they can CAD it up and just send it to you. You don't have to do it on your own. But if you're going to create custom pieces, you're pretty much going to need a CAD program. So right here is this assembly. So it comes in two pieces. It's got a main body, which is where most of the holding and pulling will go. And you can see it's all highlighted in blue right now. And then it's got a closure piece over here, which kind of inserts into the main body in these grooves and kind of seals everything off over here. So I'm going to show you what's going on in the inside here real quick before we go doing a little bit of CAD work here to check fit everything. So I'm going to hide this closure piece and show you guys what's going on in here. So this is the inside of our main body, and you can kind of see what we're going at. We have a little T-shaped section here. So the idea is the head of our hood release pole will sit in here, and then the main line that goes out towards the hood release mechanism will run out here and show up down there eventually. And then when you want to go pull the hood, you just pull up on this face at that point, and that'll let you grip a lot better than trying to just grab this wire thing between your fingers. So I think this is pretty close. This piece, this hole probably needs to get a little bit smaller. It's currently quite large. What I did want to do is go sketch up our part real quick, our hood release wire mechanism, and throw it in here and make sure everything else looks good. So we're back in our V1 assembly, and I've got the closure hidden so that I can mate things up here real quick and do our test. This is a really important part of design, is sketching up the other things around it to see if you have interferences or not. So we're going to add another component, insert a component here, and we're going to insert the release wire. So this is going to go in here, which we're gonna cheat a little bit here. You'll see how we do that in a second. But first things first, we go into mates, and this is kind of how you line everything up in an assembly so that it all works. When we're in here, you can see this piece here is already extruding in here. That's somewhat intentional. This is not that big, but interference detection between that piece and this piece. Calculate, and it'll show you, most CAD programs that are worth it will show you this, and so it shows you the areas where they're interfering and how much. So there's interference 1 and interference 2. It's going to be the same on each side based on how we mated these things together. So this is kind of what we're looking at in final before I make some modifications here. So this is way too large. You can kind of see this head will just flop around all over the place. So that needs to go away. And then I made this the head of this release wire a little too long, a little too wide. So that's not actually realistic of what we're going to see when we get there. But I wanted to show you guys a little bit of what we're looking at if we do some interference work. So I'm going to go make some adjustments to these couple parts here, and then I'll see you guys back when we're in the Idea Maker software, where we're going to actually start creating the code that our 3D printer is going to run on. Okay, everyone, we're in our slicing program. This one's called Idea Maker. It's put out by a company called Raise 3D. They make some really good products. I really like this slicer, and I'm in the process of trying to get one of their really good 3D printers. So I'm going to just give you a quick overview of how to go put stuff into your slicer here, get it set up. There's a lot more detailed guides, and in the future I'm going to do a series on like an introduction to 3D printing. This is more of a primer. But essentially you're going to find your slicer, whatever it is. This is a specialty one, but there's stuff out there like Cura and Simplify 3D and stuff like that to do a similar thing. So you're going to go in here, you're going to add V2 is what we're working with here. Going to add a part, and it's going to show up in here. and it's going to ask, hey, which extruder? The printer I'm using only has one extruder, which means it only has one head that prints. Primary extruder, yeah, that's all correct. First thing you note is it comes in looking like this. Some things about 3D printers. So 3D printers are essentially like a little hot glue gun that's sitting there melting plastic down in layers. So they can do a lot of cool things, but what they can't do is print like 90-degree overhangs. So if we look at the bottom of this thing, you see where this plastic here is just hanging out in the middle of nowhere. So if we tried to print it in this orientation, it would be terrible without any help. And I'll go over that in a little bit on our other model over here. But without any help, what it would do is it'd print this, it'd print many layers up this way, and then it'd go to make this first print, and then just, you know, liquid rubber or liquid plastic would just dribble all out over the place and be horrible. So what we're going to want to do here with this piece is we're going to rotate it so it doesn't have this giant overhang, or we can add support material. This one we want to rotate it because I'm kind of curious to see how well my printer will print these notches without any support material inside of them. So to rotate it, it's quite easy. You just select the piece, and this will change based on your printer, but you go up here and you look at the circles, figure out which circle you want it to rotate on. So it's the red circle, the x-axis, we want it to rotate on at 90 degrees. And nope, not that direction. That direction. We want it to sit on its head there. So that looks good to us. Ooh, we can even spin it around if you want to, but I don't care so much about that. And then we're going to want to move it. It could print right there, but if something goes horribly wrong, I kind of want to move it a little bit. So move this thing back over into this corner. So now we're going to print our two pieces away from each other. So we're going to have our main body here and our closure body here. You'll notice that these have the slots in the vertical orientation. See these slots? So 3D printers can bridge small gaps decently well. The hope is that this gap won't be too bad. My friend on a different printer didn't have any trouble bridging that gap without support material. So we're going to see how well this printer does with these settings. I'm sure we're going to fail a couple times here. So that's kind of how you go set it up. Some parts you can't set up really well without needing support material of some sort or another. This part, our closure part, is one of those. So you'll notice it has these tabs. So these are in the current printing orientation, which is the orientation I'm going to try and print it at. These tabs have 90-degree overhangs. They would droop just like this one would have if we'd left its orientation as it came in. Problem is these tabs also have little, can I get over them? They have little shoulders over here to lock in place on this piece. So if I were to print it on its back, those shoulders would also droop and give us really bad fitment issues and everything else. So I'm going to try and print it like this. And in order to do that, I have to add what's called support material, or supports. In this, you can have it, this program has an automatic section up here where you can just go in and add supports. And I did that for this, and I got their size down to something that's reasonable. What I did have to do, though, is the automatic supports also tried to support in here. In this groove area, which doesn't really need supports. And because the support used the same material as the rest of it, it would have essentially filled in that area. So I went and clicked out all of that support material. So this should be pretty good right now. So what we're going to do is we're going to go up here and slice this thing and put it on a USB card and get our printer ready to go. And I'll show you guys some time lapse of the printer running and driving and do everything it wants to. And we have everything off the printer. So we got our couple parts, cleaned them up. They fit together nice and snug, so I think everything will work out fine. There were some imperfections. You guys probably saw some stringing when we were doing the time lapse. That has to do with the settings I'm running in my slicer for this printer. They're not optimized yet. I just wanted to get here, get printing, get some pieces off so I could make some progress on the build. So I'm running some more calibration models behind me and trying to figure out what I need to do the settings at. And that's pretty much it for this episode of Make It and Break It on our Project Ute 300C. Next episode on the 300C, we're going to go fit this pull tab dealio and make sure it works. We're going to go check our check engine lights, see if we can't fix those. We're going to go fix our airbag lights and our front bumper covers, try and get her pristine condition for inspection, and get the inspection done at some point here. So, if you liked the video, hit like. If you didn't like it, you can dislike it. It doesn't hurt my feelings so much. It actually helps me out if you guys don't like content and you dislike it. If you like what we're doing in the channel, please subscribe. Ring the bell, that little bell icon next to subscribe, and so you get notified when we come up with new videos. And if you have any questions about anything we did today, CAD programs, slicers, 3D printer questions, put them in the comments down below. I'll be watching them and trying to be as helpful as I can down there. And that's it for this episode. Thanks for watching. My name's Andrew, and this is Make and Break It YouTube channel, where the only question we have to answer about a project is, why not? If you guys can't keep it down while I'm trying to film, I'll have to kick you upstairs.